This is RGES Algebra 1, Lesson 17A, which is a review of 7.6. So we've already had our explanation of 7.6, but I want to work with you a lot slower to help this make more sense to you. First off, we're working between the idea of an equation for the line and a graph of a line. So the visual representation on the Cartesian coordinate system, where this is x and this is y, the graph would be represented as some kind of line like this. Or if it were an equation, these are three forms of the equation of a line. The first form is considered the general form, and that's just an example of that would be if I had 3x plus 2y equals 7. I can tell from first blush that this is a line because I have one variable to the first degree and another variable to the first degree. So I know that it graphs to a line, but it's easier to graph it once I put it in one of the other two forms. Now this is called the slope-intercept form, y equals slope y-intercept, mx plus b, where m represents my slope and b represents my y-intercept. So if I had an equation that said y equals 2/3 x plus 7, I would graph that by going to 7 on the y-axis, because that's where it crosses, the y-intercept's where it crosses the y-axis. So I would go up here to positive 7, let's say, and then I would go, the slope represents movement in the vertical in the numerator and the horizontal in the denominator. So from this point, I would go up 2 and right 3, and I would get a second line, or a line here. And that is the graph of this. So here's the equation, and here's the graph. And so we're wanting to learn to go back and forth like this. Now let me show it to you in the opposite direction. If I have a graph of a line, through these 2 points, can I write an equation? Well, I notice the first one represents a point on the y-axis. So that's where it crosses the y-axis. So if I use the general form, y equals mx plus b, I can read off the graph my b and my m. My b would be where it crosses the y-axis, which is at 1, 2, positive 3. And my m would be motion in a upward or downward direction from that point to the next point. So I'm going down 2 and right 2. So recall that the numerator is of the slope is the change in y over the change in x. So I'm changing the y value, the vertical value, down 2, that would be negative 2, and I'm changing the x value over 2 to the right, that would be positive 2, so I would simplify that, equals negative 1x, or negative x, plus 3. So what have I done? I've shown it to you in both directions. First, down here on the bottom of the left-hand side, I started with the equation and I went to the graph. And next here on the top right-hand side, I started with the graph and I went to the equation. Okay. Now, we have some more to teach. That's just one idea that relates to the second equation, form of the equation, called the slope y-intercept form, or some people just say the slope-intercept form for short. Now let's go to another form of the equation. Now in this form of the equation, which is called the point slope, I have my slope here, and I have an x value here and a y value here. So that becomes my point. So this is called the point slope, because if I have a point and a slope, I can write the equation of a line. So if you will grab your book for me and go to page 299, I'm looking at the graph on the bottom of the right-hand side. So grab your book, 299, put it on pause, and come back when you're looking at that graph with me. Okay, on that graph, notice I don't have a y-intercept. It crosses the y-axis a little under 4, but I don't know the value. So I can't use the y-intercept form. But what I do have is this point labeled 3, 4. So I'm given a point, and I can read off to a second point. If you're looking at your graph, from 3, 4, I'm going right 1, 2, 3, 4, 5. And I'm going up 2. And so my slope would be always vertical, change first, up or down. Up is positive, and right 2/5. Now, so I am reading off a graph. This represents graph information that I've read off the graph, and now I want to convert that to an equation. Remember, we're always going back and forth to an equation from a graph or to a graph from an equation. So start with my general form. Y minus y1 equals mx minus x1. Now I'm going to plug in my y1, my m, and my x1. Okay, the y1 and the x1 are actual values as opposed to the variables y and x. So y minus 4 equals m 2/5, x minus, and the x value on the point is 3. So there's going from a graph to an equation. Now this equation is not very helpful, but I've already to graph in, but I've already got my my graph. So this is just the equation of the line. Now I can convert that to a different form, but it doesn't matter. Okay, so let's see. So let's look at some examples now. In the first example, it says write an equation of a line with slope equals -3 and y-intercept 5. So I have slope equals -3, the y-intercept, which is represented by b, equals 5. I have to identify which equation to use, and I'm going to use the slope-intercept equation, y equals mx plus b. I'm going to plug in for m and plug in for b. This is the simplest one, and this one you've already done in the previous lesson. So minus 3x plus 5, and that's all there is to it. Now, example 2. It says write an equation of the line with slope equals -3/4, and the point if 5, -1 is on the line. So a point on the line is 5, -1. So I have to identify which is the proper equation to use, and in this case it would not be slope-intercept because I don't have the y-intercept, but I have a point. So I would go y minus y1 equals m times x minus x1, and now I'm going to plug in that value, and that value. What is y1? That's the y value of my point. I'm sorry, that should be an equal. There we go. Minus a -1 equals, what's my m? Equals -3/4. x minus, what's my x value on my point? 5. And I could leave it just that way, except that I would probably rewrite this as a plus sign. Y plus 1 equals negative 3/4 x minus 5. Let's move to the next example. Now this is the trickier example. It says write an equation of the line containing point, it doesn't say point, but 3, 7 is a 1 point, and 5, 1 is another point. So I recognize that they've given me point 1 and point 2. Now, I would say identify which equation of the line will be useful, but I don't have a point-point equation of the line. I only have a slope-intercept, but I'm not given the intercept, so I can't use that, or a slope point. So I'm going to use the slope point formula. So what is it? Write it in its general form. Now what I have is the x1 or the x2. I could either use 0.1 or 0.2 to get my x and y value, but what I need is my slope, and I don't have a slope over here in my given information. So I need to calculate the slope. Well, recall that the slope is the change in y over the change in x. So let me figure that out. I'll go from 0.1 to 0.2. So the y values are 7 to 1 is a downward change of 6. So it'd be negative 6. And 3 to 5 is a change of positive 2. Simplifying that, I'm going to get negative 3 as my slope. Now what I have is all three. I have my point, my slope, and my x, my y, my slope, and my x. Now, I could either use 0.1 or 0.2. It doesn't matter. I'll use 0.1. So going to the general form here, I'm going to write y minus y1, which is 7, equals m, which is negative 3, times x minus x1. Going back to 0.1, the x value is 3. And that's my answer. I could have plugged it in with P2 as these points instead, and if I simplified them both, you would see that they have the same answer, and that's what he's bringing you to with the example. Now, example 4 proves that those two, whether I use 0.1 or 0.2, the answer would be the same. So you can look that over. Now, on example 5, it says find an equation of each line shown in the figure. And let's see, I have, looks like 2 lines, 3 lines, okay? So I have to be able to read the information off the figure. So for the first line, you need to have your book open for this on page 302, and let's read A and give me the information. So on A, we have 2 points highlighted. The first one is where it crosses the y-axis at negative 5. So I just read that off right there. The second one is moving from that point to the other point. The other point is above and to the left. So my changes in y is going up 2, so that'd be positive 2. My change in x value, or horizontal direction, is going left 1, so that would be to the left is minus. Now simplify that, and I'm going to get minus 2. Okay. So now I have my slope, my y-intercept, and my slope. So I would just use the Y-intercept form. Y equals mx plus b, plugging in, y equals negative 2x, and b is negative 5. just like that. Let's go to the next one. B is a horizontal line and it crosses the y-axis at 3. Now think about slope. What is the slope? Well, the y value is always 3. It's always, so the slope never changes. If the y value is always the same, the vertical change is 0. And so my answer would be y equals mx plus b. I'd plug in for m, which is 0. 0 times x is 0, and y equals 3. Let's go to the next page. It's a vertical line, and it crosses the x-axis, or the x-intercept, where it crosses the x-axis, is, let's see, I've lost it, 1, 2, 3, 4. Okay. And the slope, now what's not changing? The x value is never changing. Well, recall, the x value is in the denominator, and that part is 0. Okay. So, okay, whatever this is, that's a poor choice of symbol, sorry. Okay, whatever that is, the denominator is 0, so the slope is undefined, so I can't say anything about that, but I know that my x value always equals 4. And so that's x equals something is always represented a vertical line, y equals something always represents a horizontal line. So think that through. I'm going to stop this tape as part 1, and we're going to go to part 2 on the next tape.